Right. So we will switch gear as far as the lecture goes. We'll start talking about unstructured data. Specifically, it's text mining. I say text mining, text analysis, text mining, NLP, another word, which should have started last week, but we were disrupted by the storm. Did I hear echo? Maybe. Anyway, final exam. 99. Huh? Screenshots. 99% chance. Tuesday of the final exam week. Same classroom time. Right. So there shouldn't be any conflict. In person. Same with midterm exam. Bring your laptop. Yeah. Any conflict, let me know ahead of time. Yeah.
Is this Wednesday?
Oh, sorry. Should be Tuesday. Cross that. Yeah. Thank you. So that's going to be today. And these are going to be next week. All right, some motivating examples, which will be part of the homework. It should be fun to play with. Yelp. Who used Yelp in the past month? Raise your hand. Do you know Yelp? What Yelp is? Yeah. Again? Only a handful. 40%. I'm surprised. Yelp. I think I use it at least every month. Yeah. For comparison, let's do something interesting. Facebook in the last month at all? Fewer. Yeah, that's what I'm thinking about. It's okay. Reddit. Yeah. What else? What's the music thing? Spotify. Yeah. Okay, great. Twitter. Yeah. Twitter. Not so much, I guess. Twitter is. YouTube. Oh, yeah. I mean, all kinds. Anyway, we can do this the whole day. Let's do that. Anyway. So Yelp. Well, why Yelp? Yelp has rich text data, and it's not really a social media. It's not like Twitter, Facebook, Twitter. I guess I wouldn't say it's social media, social networks, not social networks, social media. Yes, but I even created reviews on that, and I got some votes. So, and this is part of my project, as I talked about it previously. So let's do this, interesting question, thought process. Let's say you pick a restaurant, and you can see all the restaurant reviews previously created for this restaurant. If you were to predict the next star rating that the next customer is going to submit for this restaurant, it's every 5 possibilities, 1 to 5. If you're going to predict what information would be helpful, Just go ahead and say it. Now, what information will be helpful to predict the next incoming rating for this particular restaurant? Average ratings, previous ratings, yeah, average rate, huh? Right, I'll get there. Average ratings are clearly defined. Let's say this restaurant currently has 4.5 stars. It's observable. It's either half star or full star, right? 9 possibilities. So yeah, average star rating will be highly predictive of a new rating. That's for sure. Beyond that, price level. Yeah, I think Yelp has price level for dollar price, right? 1, 2, 3, 4 dollars. Dollar tag, yeah. Number of comments, maybe, but it's hard to say which way. You know, does it predict better or worse? Unclear. And comments. This would be a giant column of all the unstructured things. What else? Let's say, so reviews, comments is review text, let's say. These are rich unstructured information. What about those structured, like already in number format? Numeric, or maybe categorical? Or other things? I think location will be predictive as well. And especially by considering location factor in terms of what kind of ratings are the other surrounding restaurants are getting. You know, it's like house price is highly location based, and ratings probably is also. What else? Number of pictures. Maybe flavor, which is more like a systematic factor. You know, maybe those who love burgers love to give 5 stars, and those who like tacos tend to give 3 stars. Just thinking out loud. So yeah, those can be predictive, but review text is our focus today, and because review text is such a column that packs almost all the information. I think if the analysis is done well, all the other information that we talked about, average ratings, price level, and flavor, other things, I think they can be almost fully recovered from the review texts if you can do it well. Because review texts, consumers can say anything. There's no boundary, there's no constraint. The only constraint is time and effort and the number of customers so far, I guess. The time that the restaurant is present on Yelp, that's the only constraint factor. The longer the time, the richer the information. So, theoretically, you can recover almost all the information from the texts. That's why it presents these potentials. Currently, when you compare restaurants, what information do you use? Those who use Yelp? How do you compare restaurants, and how do you choose the one that you are going to go? Stars? How do you use stars? You always go for the 5 stars? Right, let's say burgers. Oh, no. burgers. Sushi, let's see.
Number of these.
Yeah.
Usually it's past the dollar amount.
Oh yeah, of course. Yeah, and those are more like filter mechanism. You can filter out all the $3. Really not worth it, unless you have friends, unless it's a very important meal. Yeah. Right. It's interesting. So restaurants, we don't really compare them actually, because I'm thinking choosing restaurants it's slightly different from choosing a laptop. Let's say it's kind of different because you buy laptops every 2 years. Restaurants, you go there once in a while, fairly often. So you cannot limit yourself to the ultimate choice, if you will. The laptop, you have to do, your due diligence to choose the ultimate choice by going through, a few sets of criteria. So I think, even though we're not talking about choosing laptops, but let's frame it like that. So, choosing restaurants as if you're choosing the ultimate experience. In terms of comparing different alternatives, have you seen those? So given that you have a few important criteria, for laptops, we have CPU, speed, memory, hard drive. Normally, nowadays it's SSD size. Brand, but brand is it's different. It's not really, you cannot rank it. All those numeric things, you can rank it. What else? Weight, yeah, and maybe a few binary variables, such as screen, IPS or non-IPS, or high definition, things like that. So if you were to choose, if you were to compare alternatives, you can certainly put them side by side, 2 columns, and different rows will denote different criteria. But you can also draw a graph to compare multiple by using something like polygons. Have you seen those kind of visualizations? So things like, let's say polygon, let's say a pentagon. The 5 corners represent 5 criteria, 5 features. And the distance from the center on that corner represents the strength or the quality of that product on that criteria. Then if you connect all the dots, it's a pentagon. And then you can have different shapes of pentagon. Like, let's use a red. We have a center. So this restaurant, let's say it's average across all, because it's, the levels of the 5 criteria is at the center of each scale. For restaurants of price, let's say, star rating, what else do you care about restaurants? Quality. Quality is interesting. Quality will be the area that's surrounded by the quality is a composite measure. It's an overall judgment, and quality has different sides, including price and star. So let's say quality is the area, but we're trying to describe the different aspects of quality. Taste. Taste in terms of cuisine, it's not rankable, but we can say authenticity. Okay, how authentic it is. You know, Chinese food, Italian food, is it authentic? Location, yeah, or this, yeah, traffic time, or we're really getting academic here. Uh, ease of access, something like that. Authenticity. We can say traffic, but traffic is highly individualized. You know, it's not across all. But
just like
service, waitress service. Yeah, interesting. Uh, we don't even have place for another very important criteria. It's a, yeah, hygiene, which is important, but yeah, we can ignore that for now. Right, so let's say restaurant one is ranked mediocre on all five aspects. And then you have an alternative that is, okay, it's cheaper, but people like it. It's very authentic. It's far. You have to spend half an hour more, and you may have to wait more. And waitress sucks. Okay, that might be possible. So then this restaurant will be like this. You know, very different shape of that visualization, but you can compare two restaurants very quickly by looking at it, as long as you're familiar with the five criteria. In restaurant reviews on Amazon, you don't see comparisons like these, but you see a lot of these when you compare CPUs. You know, because those criteria are very technical and very quantitative. You can compare them very easily. Another area you will see these is esports. When you play, I don't know if you play, when you play football, soccer, basketball games on PS5 or Xbox, those players, you can compare those players, athletes, on speed, strength, you know, build, and you know, different defense, offense, you know, all those criteria, they have scores, you know, assigned to these athletes, and you see a lot of those. So you know, the point is, if you analyze the text data of anything on Yelp, you know, review text on Yelp, restaurants, hospitals, you know, anything, you can make graphs like that if you do a pretty good job in terms of mining the texts to extract information, so that to the point that the only thing you, as a reviewer on Yelp, the only thing you have to do is to write, and you don't have to assign a score. And it's possible to come up with a star rating simply by mining the texts. Of course, initially you cannot do that. You have to wait until you have a large chunk of data to do that. And Yelp cannot wait for that. So that's why we have the star rating, which also rather, you know, unique information on the site. But the point is that rich text data can support something like that. The data set that you're going to play with looks like this. This is actual screenshot of the, you know, data set in Jupyter Notebook. And it has 15,000 rows for maybe 2,000 restaurants, maybe hundreds of restaurants. Some of the restaurants are very popular with thousands of reviews. Unstructured data is, the potential of that is being discussed everywhere, and healthcare is one area where the stakes are high because data is so much, and these data has rich information that is actually being used. Doctors' notes are being used. Nurses review them. Doctors review other doctors' notes about this patient. If the patient transfer, into a different hospital, and so discussions between the patients or patient's family with doctors will refer to these other doctors' notes. So doctors' notes are being used, but only manually, by actually reading it. So the potential for data mining techniques to help the process to drive the healthcare delivery process will be enormous. The only thing that's lagging is development. I would say, the vast majority of the talents in machine learning is working on computer science and those profitable areas. VCs, and someday soon VCs will start to deal with these problems. But VCs are mostly dealing with, are hired by Google, Facebook, Apple, because they earn a lot. Healthcare, not so much right now, so they're lagging behind. But the potential is starting to being realized. I think more the academic scholars drive the train here, versus those highly profitable areas, social media and tech companies. They hire people internally to do that. And coincidence, maybe coincidence or maybe not. The homework that you will do will deal with Yelp data. But the research I talked about is more about healthcare analytics, right? Reviews about hospitals that look at the effect of a Yelp information design change on hospital subsequent reviews. That's what I talked about the transfer deep learning. So anyway, healthcare analytics is one of the hottest areas, particularly with natural language processing. This is the data set you'll work on for the homework. And so let's transition to look at the kind of data that you will get by scraping the data from Yelp. Mostly I'm talking about the texts. If you develop a Python program, maybe it doesn't have to be Python, but R, maybe something else, C#, I think you can do that in C#. VB, maybe. I don't think VB, maybe, but ASP, yeah, ASP.NET, you can do that. You can use multiple languages. But regardless of language, you're dealing with HTML. So the text data that you see that's displayed on the web page, they are decoded information. Most of them are the same, especially those letters and some of the punctuations, like dot, comma, easy punctuations. They should be stored similarly in Yelp database. But those other special letters like line break and ampersand and maybe the brackets, they may have to be encoded to be a string of symbols to be stored in Yelp's database. So when you collect data, you will start to see, you'll see symbols like these. I'll talk about what they are. The exam has questions that deal with these specifically, and that's why I talk about them in detail. Megan said some of the videos I posted on YouTube do not fully cover what I talk about here, so you may want to pay, attention to what I say here, or review the video afterwards. So the videos on YouTube mostly cover pre-processing, but does it deal with HTML data cleaning, or do you have a sense?
Are you asking me?
Yeah.
They could have kind of a capture this later down in the file, maybe. I actually, when I saw that it wasn't matching perfectly, I decided that I come to class first and then watch videos later.
Mm-hmm. Okay. So right. So about cleaning the dirty symbols from HTML scraping, you want to pay special attention here in the lecture. Okay. So what are these? These look like random symbols, but they actually refer to something. They are because of text encoding in their technical systems, and then somehow got mixed when you scrape data from their website. So I don't know who's familiar with HTML programming. Great. You probably recognize some of these. HTML is basically tags everywhere. So tags are wrapped by these symbols, less than and greater than symbols, pointy brackets. They are not actually brackets, but these are looks like brackets. Tags. HTML is full of these tags. There are different kinds of tags. It can have attributes. It can have different types of tags. They have names, and they have attributes. So basically, is the backbone of HTML. And a special kind of tag is this, or sometimes it's written as there's a space, slash, and that. These are line break. These breaks is placed at the end of a line where any symbols that come after that will be moved to the next line. So that's the encoded value of the line break. But somehow you would expect this, but not that. But ampersand GT and semicolon. And these internally means that. So somehow, they mix together when you collect the data, and you start to see both, very awkwardly. But internally, they code it as that. If you put that together, it's that. So if you were to search for this, you're not going to find it, but you're going to find these line breaks. And they are invisible. When you print the text data after you collected it, you don't see anything. You just see a line break. I mean, you see a new line. But actually, the line break symbols are there that gets rendered when you print it. So, so these text data, when you print it, you can't see them. It's invisible. When you display them, you can see them. That makes a difference. So, but the thing is, tags it can come in different shapes. You can have this is A. It's basically this. This is an A tag. What is an A tag? What is an A tag? A hyperlink. A tags are hyperlinks. You typically have where you would put URL. This is hyperlink reference that will redirect the page to that particular URL when you click on it. It's A. And typically, other than the line break, which is typically exists standalone, all the other tags will have a beginning tag and end tag. It's a pair, the beginning and end. That's why when you say the A tag, we have the A, and if you translate in your mind into that symbol, then that compares the tag. But you have the beginning tag and you have the end tag, and translate that to the greater than symbol. You have the /A. So all of these we have to deal with it. Otherwise, program will get rid of that and will retain the A, which is not really part of the text. You want to clean the text to remove these holistically instead of simply removing the punctuations, the symbols, but leaving these awkward, AMP. What does that mean? If you don't clean these, if you only clean the punctuations, the review text, those review texts that tend to be long will have a lot of line breaks, have a lot of quotes, quotation marks, and these AMPs will be everywhere. So AMP will be a common word in your text, which is meaningless. It's really meaningless. So it can become one of the key predictor, which is not really helpful. So these symbols better catch the trend, catch the pattern, and deal with it, elegantly. And you can really do that by using the regular expression. So learning the basics of regular expression will help you clean all of these quite easily. But although the regular expression is kind of complex, there must be some learning curves initially, so be prepared. But I'll walk you through some basic use cases, and let's see where that will take. And this is a rather very peculiar symbol in coding, and it doesn't change. It's basically you recognize it and you use a pattern to identify that. That's it. But be careful with any escape. That's backslash symbol. Backslash symbol is escape symbol. Remember when you print something, and when you want to print some of the special symbols, like so you have a string. This is a single quote. Within your string, if you want to print another quote, you cannot do that because that program will think you have, the string have ended. So you have to use a escape symbol to escape that before you can print that. So escape symbol is a special symbol. To include escape symbol itself, you have to use another escape symbol to escape the escape. That's the way it goes. So I'll show you the demonstration when we get there. But together, this encoding is for space, basically. So in HTML, when you want to include space, you cannot simply include a space. It's not recognized. You have to encode the space symbol. So that's why this one gets in. And here we have single quotes and double quotes. and we have kind of like, I have two semicolon and with a number coding. This ampersand, so single quotes is in encoded format, it's actually this. So ampersand hashtag 39 semicolon, but this ampersand is double encoded, and then it becomes ampersand AMP semicolon hashtag 39 semicolon. So that's why you look at the data, this is what it shows. It's like escaping, but this is encoding. So the ampersand gets double encoded, becomes that. You translate that into ampersand and put that together, it's a single quote. Double quote, the same. And this is where it becomes clear. You have double amp, which means the ampersand is double decoded. You translate this part to ampersand, and then take this part, it's an ampersand. So that's why you see double ampersand. This is another, this is essentially the same, but sometimes it shows up like these, sometimes it shows up like that. So all of these, you know, you might think it's easier to simply, to find them literally, and you only have to find 10 times, and you can remove them. But these are just a handful of all the possibilities. You have all the other possibilities, So maybe Yelp only has these, but if you collect data from Google or collect data from other websites, not necessarily in the patient in the doctor's notes, because those are EHR systems that are different. But if you collect data from online, you will see other string symbols that may be beyond these. So better learn how to use regular expression to construct a pattern and be prepared for different possibilities. So that's what I'm going to tackle now. To be able to use regular expression, better to learn these techniques. These are a few important ones. So the first very important one is the character set, square brackets. First of all, in regular expression, there is a reserved list of special symbols that are not searchable. All the brackets are, including the square brackets and parentheses. So if you want to search, let's say you want to search square bracket in the review text, you cannot say, I want to search square bracket. At least in the pattern, you cannot do that, because this is reserved to indicate a character set. To find that, you have to use escape. So that's the point about special symbols, particularly for regular expression. Okay, so what's the use case for character set? Let's say you consider different possibilities, and you want to find a character that can be multiple possibilities. Let's say it could be A or B or C, or any of these. It could be A or B or C, but just one of them. So in that case, you can do A, B, C. These are all inside quotes. So so these are patterns, regular expression patterns. You have to put them in quotes to represent a string, and use the square brackets to indicate a set, different possibilities. It doesn't mean ABC literally. You can do B, A, C, and square bracket, hold on. The same thing, exactly. ABC, BAC, order doesn't matter. It's a set. Indicates one of these, one of these possibilities. But the good thing about future set is, let's say you want to do A to all the way to Z. You don't have to spell everything, 26 letters. You can do a range. So basically it's a dash, common dash. So A to Z, feature set, that includes all the 26 letters, lowercase, right? To do uppercase, simply include uppercase. So this is according to AC, what is it? ASCWI character set. Yeah, if you understand basic computer science, you'll know what I'm talking about. These are how the letters and characters are encoded in computers. To do capital letters, you simply include capital A to capital Z in a character set. So these are all different possibilities. What if you want to do all the letters regardless of case? Include both A to Z, A to Z. That's lowercase. And even better, because capital letters are ranked first. So they appear first. So you can do A to lower Z. That would include 26, double the 26 letters, uppercase and lowercase. So that's character set. You don't have to be confined to these different ways. You can mix and match whatever way you want. You can do A to Z, ampersand, ampersand, it's not special character. Dollar, comma, period, explanation, anything you want. Just add that to the list, to the set, and it will identify anything that falls into this character set, but only one at a time. One at a time. Can't emphasize more. One at a time. It's not a literal word. One at a time. The order doesn't matter. You can move them around. Doesn't change the result, as long as it's in the list. But you cannot move these group. A to Z means a range. You cannot do Z to A. It doesn't work. Have to follow the order. And other things you can move around. So that's character set. It's very powerful. But it's not only that. You can do the complement. When you have a set A to Z, you can use the caret symbol. It's always put at the very beginning of the character set within the pair of brackets. So it's put right after the left bracket. If you put a caret, that means anything but these. It's completely opposite, a complete opposite set of the current set. So you want to understand the current set, and then it means anything but. Okay. So what is anything but A to Z? Give one example. What is? 6? Yeah. One more.
Special character.
Yeah, like what?
Asterisk.
Yeah, asteroid. Yeah. Wait, what's asteroid?
Just asterisk.
Oh, star.
Yeah.
Yeah. Right. Clearly. So all the possible, and even spaces. right? So that's it. So that gives you a powerful tool to construct any set that you want, basically. As long as you're clear what set do you want to construct. So that's that. Escape symbol, I talked about, it's special for special purposes, especially for brackets, you know, square bracket and this one. To give you a sense, let's see. So this is what I talk about. The A tag has a few features, and then you have you see the actual link text where the URL is embedded behind the strings. Special characters, including all of these. Dot, even dot, didn't realize. But caret, even asteroid. Yeah, asteroid, yeah. That's within a set, maybe. Within the set, it's not special. Outside the set, it's special. But I'll talk about it. So curly braces and square brackets and parentheses, these are all special characters. Okay, when you are, there are special characters to refer to alphanumeric characters. What is alphanumeric characters? Alpha is alphabets. Numeric is numbers. So that includes A to capital Z, lower a to lower z, 0 to 9. That can be 99 if you repeat it. So we'll talk about repeating. These, that's alphanumeric. So that would be the escape lower W. Escape lower W includes all the possibilities here, as well as an underscore. Very strange, but underscore is included because I guess it's too lonely, and other sets don't want to include it. That's why it's included here, maybe. But so escape W includes all these plus the underscore. So, when you're tired of having to do these, you simply use, escape W. We'll talk about that in a few. And escape D, not used very often, but can be useful sometimes. D is digits. So escape D is essentially saying, so escape D, these are all included in the character set. Character set escape D is equivalent to character set 0 to 9. So that's escape D. Escape S is quite useful. It's all the white spaces. Spaces, line breaks, what do you call it? Anyway, I think I showed it here. Non-breaking space. All the invisible symbols. They are called white spaces. So all of these are lower cases. Be sure to note that. If you use capital letters, that means the complete complement, the complete opposite set of the lowercase. So this would be A to Z, lowercase 0 to 9 underscore, but with a caret symbol. So it's anything but the escape lowercase W. Right, so same thing with that. Capital D in a character set means anything but digits. Anything but capital S, anything but white spaces. So you can do all these different combinations. Okay, so all of these are interesting, crazy, many possibilities. But so far, the character set only identifies a single character. So let's see the demonstration. I'll have to switch virtual. See the screen. Right now, can you confirm you can see the Jupyter notebook?
Yes, I can see it.
Okay, great, thanks. So I have these 3 example reviews of restaurants. We'll practice with them. This list is the same as I show in the slides. Okay, we put the character set pattern under the pattern parameter. We mostly use 2 functions of regular expression. One is to find all, to locate everything that meets the pattern. The other is to sub. Sub means substitute. We want to find them and replace it with something clean. And so the first function, to find all, if we use this pattern, character set A to Z, it will find everything that is from A to Z. But it will find it as individual symbols, individual characters. So if you try to find it in this string, the order of the, if you remove, if you skip the argument name, you can do that. But in that case, you want to make sure you put them in the right order. The mentality here is to find pattern in string. The pattern comes first. To make sure there's no errors, you can spell out the parameters. Then you can switch things around. So to find patterns in a string, to find these patterns, lowercase characters in capital letter S Superman, it will find all the letters except S, right? Because S is capital letter. It will find U, P, E, or M, A, N separately and return a list. And even if sometimes you only find one instance, it will still return a list with only one item. So the argument that's returned, the outcome is always a list. Even if nothing matches the pattern, if nothing is found, it will return an empty list. It's an empty list. It's not nothing. It's a list with empty elements in it. Okay. So don't compare it with non. It's not non. It's just empty list. So, we can change things around. If we change the lower a to capital A, it would have found everything, including the capital S. So if you run that, which is here, you find all of those. Or you can say, spell the letters in any case, but use an argument for flags. Say you ignore the case. If you ignore the case, it will find these letters regardless of the case. It will find all the letters, including capital S. So that's simple use cases of character set. But you can imagine the power is boundless. You can have superpower. Superpower with Superman. I think for a moment I escaped. And now I'm back. Anyway, so the caret set, caret symbol I said, the caret symbol is the complement of everything that you put into the character set. So if you put caret before A to Z lowercase, it's anything but lowercase A to Z. So we'll find only S. And now I include an exclamation, so it will find the exclamation. with the explanation, with lowercase caret stat, but ignore the case and only find the explanation. With capital letter and lowercase, and to find it in Superman, it finds nothing because everything is, I guess, there's nothing in the complex set of the alphabetical letters, so it returns empty list. Empty list is an object of a list that does not have anything in it. It doesn't mean it's none. Okay, be sure about that. Okay, so I think we might have a Teams connected in the room. That's what happens. So if you would at least mute your mic. No, mute your speaker. Mute your speaker for the laptop. And then we won't have that problem. Right. Okay. So let's do some exercises. Let's do capital letter, space, dot. So it's a string, S. Okay. So let's try to find, So construct a pattern that will identify all the other, to identify everything but capital I and capital P. How would you construct that? So you want to come up and run on the board? Why not? Well, there can be multiple ways, right? Do we have a whiteboard? Anyway. Volunteer? No? Anyway, so how would you so anything except I and P. Okay. Yay. Yeah. The board is all yours. Sorry, the other one. A to Z. What is it?
The ampersand.
Ampersand, period.
I don't know how to draw the other one.
Wait, ampersand is fine.
Okay.
And that's period.
Yes, that's a period.
So it finds everything. Oh yeah, there's period. What's the ampersand for?
Do you include the period? Do I not need to put that? I just put the period.
Right. Leave it. Right. So to include more symbols in the set is simply including. Including ampersand means it will find ampersand.
Oh, okay.
Right. I should say within the character set, the ampersand is not a special character. Dot is not. I think so. But the dash is. It is a special character. It will not find dash. It will treat dash as a range. So this indicates range from A to Z. But I'm not entirely sure what will happen if you do this. Because technically from Z, from lowercase z, it's not valid. So in this case, it could be, there are two possibilities. It could be that Python will give you a bug. But say, this is a bug, fix it, error. Because it doesn't work, A should be before Z. Or, because it doesn't work, it will treat Z, A as characters, and treat that as characters as well. So we're trying to find dash as well. But I doubt that will be the case. To find dash, would have to escape the dash. That's what I think. But that possibly remains on the table, until you test it. So you don't need ampersand, but including it will not do harm, because there's no ampersand here. It will simply do nothing. But you can include that, of course. And doing this will find everything but the two capital letters. Yeah. Good job. So any questions on this? But you know that if you do that and use the find all, you will find what will be the first character that you will find? Space. Yeah, that means space. And the second? L. And, and so on. So the individual characters. But what if I really want to find let's see. I want to find love. And I want to find Python. So I want to find words, strings of characters, instead of individual characters. That's more interesting, and that's actually more common tasks instead of individual characters. You can, if you want to remove everything but the capital IP, you can still use what we had here is A to Z and dot. You can use these and find everything that we need to remove, and you say replace with nothing. That's sub. Sub. Find the pattern, replace with nothing. There's not even space in here. This is empty string. To replace that, what you get is IP in the end. That can be possible, but a lot of times you want to separate the I and P. You don't want them to be close to each other. Separating them is useful because you want to later treat them as separate tokens. You don't want them to lump together, right? So in that case, you would have to replace with something like space. So if you find them individually and replace each with space, you'll be left with a long string of space. That's cumbersome, So better way is to identify love together and replace it with a space. That's at least fewer spaces, if you can do that. So the question is how to do that. And on that, you will have to use these symbols. Okay, so what does that mean? Asteroid means, so I'll write some numbers and I'll explain. And okay, so asteroid that follows a character set, which means when you have a character set, you know, anything that you include followed by asteroid. That means the character specified by the set repeated for 0, 1, 2, or more times. So essentially, without or with infinitely. Okay, so what does that mean? Let's say Superman, that's the string. And if you do a character set, lower A to Z, and use an asteroid, what does it find? It finds, huh? No, it doesn't find numbers. Number means the previous set being repeated for a number of times. It doesn't find the specific numbers. Asteroid means absent of that, or any possibility within the set that's repeated 1 time or 2 times, 3 times, or infinite number of times. This set finds only lower cases. With an asteroid, it means lower cases repeated for 0, 1, 2, or infinite number of times, unless you see otherwise. You know, non-lowercase number, non-lowercase letters. So in Superman case, it will find this portion, Uperman, together because it's the string of lower cases uninterrupted until the end of the string. So it will find this string and return a list of only one item, which is Uperman. That's what it will find. Make sense?
Without the S, because S is capital and others are small.
What do you mean?
So like if we remove the asterisk symbol from,
Okay.
From there, so still then we would get Uperman because those are all small. Letter
Okay.
S is only capital.
That's a good point. Let me. What did I do? Anyway, I guess I cannot change. Keep. That's a good point. So if you compare these directly, single quote, doesn't matter. Single or double, doesn't matter. If you compare these two without asteroid, right? These will find you a list with only one item. This will find you U, P, E, you get it. That's the difference. That's the difference of repeating characters. Without repeating, it finds individual characters as individual results in the list. With repeating, it finds a string of letters. So that's why if you look at the these, okay, with repeating, this is kind of longer. Okay, first of all, be familiar with this pattern, let's say. So it's kind of complex. We have an escape parenthesis. Parenthesis needs to be escaped. So, and that's actually before the set. It's very complex. Anyway, I don't have easier. Right. So to find the square bracket, this string is square brackets with quoted square brackets, and parentheses, also called brackets, especially in American English, and parentheses are mainly used to enclose words blah blah blah. And this is one string, stitched together. This is one string, although it's very long. So in order to find, I'm going to find the square bracket, space, and square bracket. That's the purpose. So I'm going to find the three characters together. These three characters together, square bracket, space, and square bracket. To find that, I need to include escaped square bracket, include a space, include that. So there's no character set here. Be clear, because the square bracket is escaped. There's no character set. There's literal, it's a literal string. 3 characters, literal string. So it will find a literal string. It will find these 3 together and find it. To find only one character, which is this, to find the beginning of the parentheses, you use escape parentheses, and it will find escape parentheses. Okay, this list means the outcome, right? Clear? So we'll work with the same string, but I'm here to demonstrate the difference that's made by the asterisk and repeating strings. Okay. So observe this pattern. We have a character set in the middle. This is a character set, which specifies all the alphanumeric symbols, right? A to Z and 0 to 9. So all the alphanumeric, you can almost use this. Escape W, but escape W also includes underscore. If you don't want the underscore, then you can spell out the set. So A to Z and 0 to 9 alphanumeric letters in a character set that will only identify one. Anything of them, but only one time. It cannot be repeated. And then you put the escaped parentheses before an end, it will try to find things like these. It will try to find things like these. Okay, it will try to find things like these, or parentheses 8. But it will not find with 8 repeated. It will not find that, because according to the pattern, you have escape parentheses, you have a character set A to Z, 0 to 9. 8 will satisfy, but it should be followed immediately by another parenthesis. It's not followed by parentheses immediately. It will not qualify this as one of the results. So we'll not find it. If you run the codes on this, it will not find the entire string included in the parentheses, but it will return empty, because even this doesn't, here, not that. So it will not find this portion, even if it begins with parentheses A, but the third character does not qualify as part of the pattern. That's why we'll not return it. But as soon as you include the star, and see that we also have spaces, so that's why I include the alphanumeric sets and the white spaces as part of the set. But I use asteroid that allows it to repeat 0 times or many times, it would, well, at least it will be closer to be able to find that. But you see that one difference is, one exception would be the comma. If you don't include comma, you will still not be able to find this entire parenthesis clause because the comma will break the pattern. As soon as you include the comma, you will be able to identify the long string. So the point is, with asteroids, without, let's see, draw a pointer. Without asteroids here, it cannot identify something like this. As long as you include asteroid, it will find something like that. Even with the asteroid, you will be able to find an empty parentheses pair because it can allow 0, right? But if you replace asteroid to question mark, not question mark, if you replace it with plus sign, which is, plus sign is the second. If you include it with plus sign means anything beginning with 1 time. It has to appear 1 time at least. One time, twice, 3 times, or infinitely. So with plus, you will be able to find these, similarly with asteroid, but you will not be able to find these because alphanumeric numbers or characters are not repeated at all. So empty, like, non-existent. But question mark can find 1 time or 0 times. So that's the subtle differences. I'll let you kind of, process that. And we have some examples here that will demonstrate that. I think with, let's see, here. So we are trying to find parentheses with numbers in it. So we have the example string here, 1 Superman, 2 Spider-Man, Batman, Ant-Man. We have empty parentheses. We have parentheses with 100. So 3 different possibilities: empty parentheses pair, parentheses with only 1 number, parentheses with 3 numbers. If you use, what is that? If you do not first of all, escape D is the digits. So all the digits will be found inside the pair of parentheses. Inside the pair of parentheses, it's the character set. If you do not include these special symbols, it will only find those parentheses with only 1 number in it. So 1, 2, 3, 4. If you include asteroid, it will find these as well as the empty parentheses pair, as well as the one with 100. So any number of digits inside the pair of parentheses, it will find it, even the empty ones, right? Because it's asteroid. But if you switch it to question mark only finds 0 or 1. So it finds the empty and finds the single digit parentheses, not the 100. And finally, if you use plus, it will not find the empty ones, but it will find anything that's repeated X number of times. So that's the subtle differences between these repeated patterns. You will, use them creatively based on the problem that you're trying to solve. And every problem is different. Every problem is unique, so it requires a unique solution. Megan, are there videos on these? No? I guess not. So
I didn't,
lectures.
I didn't see it on this, but I didn't watch all the videos, and when I started watching this lesson.
They should follow an order. If you start to see some videos that are for contents that are behind these, then there shouldn't be any contents that are for these. You watched it?
Yeah.
Okay. So some of the videos include these. Great. Anyway, so so that's that. And so once you find the patterns, once you find the characters or strings that meet meet the pattern, then you can replace it with clean characters. You know. Is it? Let's see. Oh no, it's live caption.
No, someone's messaging you.
Someone? Why don't I turn off? How do I? Okay, no, not these. Here.
Yeah.
Dr.
I don't see any.
It's for some other class. It's
They're messaging in person.
Oh, it's the, it's in chat.
Yeah.
Okay, it's not time sensitive. So we're fine. Anyway, it's just chat. Okay, so once you're able to identify the strings by using some patterns, you can replace it with some other strings. The function you use is sub. So the pattern is sub function, is meaning substitute, right? Substitute pattern, which will identify the strings, with substring, with replacement string in a string that you know, which is the data. So, you know, three required arguments. You can add a fourth, which is, you know, you can ignore cases. That's one of the options. It actually comes in handy in some of the unique, peculiar cases. It's very interesting. If you go through the slides demo, you'll find in one place that does almost seems like magic, but you know, unexplainable. If you don't use the ignore cases, it successfully finds a pattern. If it include ignore cases, even if the pattern doesn't regard any cases, it failed to find it. So you know, sometimes you have to experiment with different ways. And you know, so review these for additional examples and use cases to you know, better understand the regular expressions. I think I should move on to the next subject. Any questions about regular expression? So after the class, review these materials and you know, trying to understand these, at least those patterns, character set, and common escape sets, and the caret, right? And look through the demo examples, try to understand them. If you have questions next time, we can discuss them. Okay, I'll briefly talk about how I collected Yelp data, the process and the challenges in between. And I think that's all I plan to talk about. Right. So see. So at this point, if you need to go, feel free to go. If you're not interested in how Yelp data is collected, but feel free to stay if you're interested. We'll spend maybe 10 minutes, 15 minutes. So it started from a research idea, but later that research was stopped. But everything I had about the data collection gets reused for a different project, which you know uses Yelp data as well. But the context is not restaurants; it's hospitals, as I talked about. But now we have started another project that uses Yelp restaurants. So it's great that I collected those data in the back. Yelp, you know, is a very mature consumer service review websites. that kind of survived all the years. Started from 2005 or maybe 04. Did you still remember 2004? What happened back then? Well, 911 happened 3 years earlier. Where were you when 911 happened?
Class.
And I hear,
I didn't even know what that was.
yeah. So how old were you in 2001? 5? God bless you. I 10, 11, 9. Okay. Didn't know anything about it. Well, 'cause if you live in New York, you will have impact to you. Yeah, I was in high school. Not high school. Yeah, high school, first year. Didn't feel too much back then because, but you know, it's a major disaster. So 2004, around that time, before Apple was born. Apple probably was in the lab, development, but before Apple was born. Yeah, early days of the dot era, right? eBay's, PayPal, Amazon, probably by then. Yeah, so, and kind of Yelp survived all along. And there have been some contenders to Yelp. Urban Spoon, if you know about that. TripAdvisor, but doesn't really go into the restaurants, but hotels, TripAdvisor. And yeah, but Yelp actually survived. Rich amounts of data. Yelp is still one of the big techs of Silicon Valley. So collecting their data is not as easy. It was easier. The first time I collected their data is 2009. I was my PhD program, and I already started doing some work back then. Back then, somebody else helped me collect the data. He used ASP.NET. Sorry, no, he didn't. Yeah, I think so. ASP, but it's mostly the backend program that collected the data. And after 2 days continuous scraping, back then scraping was not as common, and websites don't really watch out too much for it. But after 2 days of continuous scraping, the IP was blocked. So Yelp finally realized, so this is a bad guy, so blocked it. So we had to use some kind of VPN to keep collecting. But the whole collecting finished in 3 days. So got the data, did the work. And fast forward 10 years. Yelp is better equipped. As I was testing in early stages of the research, 2018, late stage of 2018, I tested the program, continuously collected for maybe an hour or so. IP was blocked. It was blocked for 2 months. I couldn't use Yelp with that portal, with the same laptop, for 2 months, and finally it removed the block. So you cannot continuously collect a large website, because they are better equipped. They can monitor IP more accurately. So over time, the program experienced several generations, like rockets, several generations of programs, and better equipped to I guess, to counter IP block. And so the challenges are capture. CAPTCHA. Capture is really backed by Google. So it's Google service, and many websites use that service. The purpose is to prevent bots to collect data, basically. Prevent bots to do damage. Not only scraping data, but bots can register accounts, can generate fake reviews. So Yelp doesn't want that, of course. And so Google, as a #1 tech company, they develop Capture and provide it as a service to any websites that subscribe to that service and pay for it. So as soon as Yelp suspect that you're a bot, it will display this. And we have tried to, so what you need to do here is to click that tick box, and then after clicking that, you have to click the submit, wait for the page to reload, and then the suspicion is cleared for temporarily. You can, even as a human, you can still get this page. It's just because of false alarm for Yelp, but it's not that annoying. It doesn't come up very often, but in collecting data, it comes up very often. So we have tried to use programming to do that, to click that box, to click that button. Doesn't work. You would think that it's doable, but I would say, Google is out of my league. So I just, cannot deal with that. So I have to do it manually. But what do? You let the program run and just check back randomly. What if it's blocked? If it's blocked, but if your program continues to request data, then every page that you request since that point of capture is going to be failed. So no data is collected on all the pages requested after that point, because Yelp will continue to block that request, the requester from there. So until you realize you have a unknown sequence of data that are missing, essentially, because the page doesn't have the information that you need. So if you deal with it retrospectively, you have to identify at which point that occurred, and you have to restart the program from that point that capture started. It's very time consuming, I tell you. It's very. So that was the first generation, and then that gets updated. Several generations later, what we did is we cannot use program to overcome the step, but we can use program to identify it. So what we do is upon every page request, we will try to identify capture. At the beginning of the program start, there's no capture. But let's say after an hour, capture start to appear. Because the program will check page for capture on every page request. As soon as it starts, it detects capture and it temporarily stops the program. It will stop requesting more pages. So that's the first improvement. At least from that point on, there's no missing data to deal with, and the program is not really stopped. The program is temporarily paused, and the program will wait for human response. So at least the missing data problem is not getting worse. It's kind of solved. But the problem is the program is paused, no data is collected. Someone has to go in and deal with it. But the problem is, how can you predict when this will happen? It's hard. Over time, after a few generations, I realized that it happens roughly 1 hour, 5 minutes after continuous collecting, 1 hour, 5 minutes. And it's so consistent that you can almost predict. But so what happens is let's say I start the program 8 a.m. this morning, and I have to immediately set an alarm for 1 hour, 5 minutes, and I do something else. Alarm goes off, I come back, and apparently capture. So I have to click submit, and go back to the program and say continue. The program has this user interface that says, capture is detected. You want to solve it. And then I do it manually on the side on the same computer on a random Yelp page. Click the capture and come back to the interface, say continue. So at that point, I have to set another alarm. So you can imagine, if I collect 14 hours of data collection a day, I have to set 11 times, alarms. So that went on for a while, and then one day, an idea came to me. Why don't I text myself if it detects a captcha? I can use program to send a text message to my cell phone. So I searched around for different providers and found Twilio. Twilio is a service provider for cloud services, mostly for marketing. All the junk messages that you receive on the cell phone, probably half of them are from Twilio. It's backed by Twilio as a service provider, and this this grocery store sends you a coupon, sends you a reminder about a deal on your cell phone, to your cell phone. The service probably is backed by Twilio. Twilio stock is pretty good actually, 150 or so, has grown especially through the pandemic, because these services are very popular. But anyway, so I did that. I subscribed to the service, and to send a message to my cell phone, as well as my collaborators, after we have kind of collected in scale Yelp data. So send a text message to myself, and after I receive the text message, I go to the machine. I usually use it as remote machine. Use Google Chrome remote, which is very user-friendly. Even if I'm driving, I'll do that because it's quick. I remote in, I click captcha, and go, right? I don't have to set an alarm. That saved a whole lot of trouble. That increased productivity. That essentially removes all the stress. You can imagine all the stress. So that solved a lot of problem. And the cost, it's almost nothing. One text message is 1.8 cent US dollars. So over time, I probably have sent myself 60 messages, and I had a $10 promotional credit to start with. So I haven't spent a penny on that so far, and that has gone very, very well. So that's capture, but IP block is a more severe issue. IP block should be prevented at all costs, because to find a new IP that can work for you is not easy. So to prevent IP block, you don't want to continuously request pages. So the way I do is over time, and you have to, draw the line, because you have to evaluate your demand, the amount of data you have to collect, how long do you have for collecting those data. You have to estimate the scale of the project. So for me, it's not as I guess urgent to collect all the data at once. So what I do is, between page requests, let's say each page request is a page of several Yelp reviews. Yelp displays 20 reviews per page for restaurants. So that is one page request. In one page request, I can get 20 Yelp reviews for one restaurant. So what I do is, between page flips, I let the program sleep for between 1 and 15 seconds. And I use programmatically, randomly to disguise, as a human, because if you pause every 10 seconds, it will be easier for y'all to detect that it's a bot. So think techniques like that. And also to better anticipate the captcha, I let it continuously collect, but with the small pauses in between, continuously collect for 50 minutes, and then just wait for 15 minutes. And then as soon as it restored after the 15-minute nap, it capture almost always will be detected as after nap. So at that point, I will get a text message, go in and clear the capture. And since it has taken a nap, it will continue for another 50 minutes. And then nap, and then capture, and then clear the capture and continue. So you can do 14 hours of that every day. And my student and we collected data from Dallas and Houston, not all of them, because at some point we stopped and the data is enough. But we collected almost, I think, 6,000 restaurants. Some of the restaurants have thousands of reviews, some of them have fewer, but at least 100, I'd say, 5 pages. We collected almost 5,000, 6,000 restaurants for me and my student, simultaneously collecting with each with one computer. I think I used 12 days to collect 2/3 of that. And my student sometimes did it, sometimes didn't do it. He's not very, programming sophisticated. So he's mainly using the program without knowing what's happening behind it. But I think he used 1 month to collect 1/3 of that 5,000 restaurants data. So in the end, we have, and I take a random sample. That's the data set you're working with. That's a restaurant data set. And these are all the variables inside that. So that's all. That's all the backend stories with the collection. If your company needs to collect data, I think I can help. But without telling wherever the data is coming from. That's it. That's it for tonight.